Greetings, everybody. So here's a problem that I think you'll see at some point in our assignment on my math lab. And I think it'd be a good one to go over because it involves selecting the right graph for this situation. Now, I'll let you read this on your own. I just want to summarize the information and tell you how you'd go about solving a problem that's like this, okay? So here it is. In this problem, you are given a population. In this case, that population is the annual salaries for a bunch of people for a certain occupation. It might be the annual salary of everybody at a company, okay, or something, everybody in a state, or something like that. But there's a population. I am told, when I read this, that the mean annual salary for this particular occupation for everybody in the population is 122,000, okay? And that the standard deviation for that population is 20,000, okay? All right, so that's what I'm given. If I read a little further, it talks about taking samples from this population. So there's this population. It's a whole group of people at a company or a region or something. And we take samples of size 29 people, okay? And we want to say, well, suppose we take the sample size 29 and we find their average salary, their mean salary. What's that number going to be like? Okay, well, regarding that sample of size 29, I can say three things. You take a sample of a certain specific size from a population, okay, and you find the mean of that sample. That mean will have a normal distribution. It will have a mean of mu, the Greek letter mu, which is the same as the population mean, in this case 122,000, and it will have a standard deviation of sigma being the population standard deviation, over the square root of n being the size of the sample. So in that case, that's 20,000 over root 29, and so with some rounding, that's 3,714. Okay, so those samples of size 29, the averages of those samples, I can say these three things about: normal distribution, mean, standard deviation. So if I wanted to calculate what's the probability that the mean of the sample is this number or that number, I could use a normal distribution like so. Now, in this question, initially it just says, well, as far as this these samples of size 29 go, their distribution, okay, has a mean of 122,000 and a standard deviation of 3714. Okay, so that much I showed you how to calculate with those formulas. Now beyond that, it says, what would the graph of the sampling distribution look like? Meaning, these samples of size 29, if their average or their mean is a normal distribution like this, what kind of graph does it have? Now, all of these look like normal distributions. Normal distributions look this way, okay? This peak, now they're symmetric, so it's also called a bell curve. Maybe you can see why you might call it a bell curve. This peak, this highest point, is located where the mean is. And by the time you get 3 standard deviations away, you've covered basically the whole curve. All right? So this is how I'm going to do it. I'm going to figure out which one of these would be correct. For our case, normal distribution, mean 122,000, standard deviation 3714. I'm going to figure that out by saying that it will look like this, and I just have to figure out what these numbers are. So here goes. The mean's 122,000. That means this point where the peak is has got to be 122,000. That allows me to rule out 2 of these. So this might be a normal distribution. That is what they look like right there in this picture. That does look correct. But where's this peak, this highest point? It's at 22,000. Well, that's not right. It needs to be at 122,000. So I can rule this one out, and I can rule this one out. So the answer is either A or B. How do I decide between A or B? Well, from wherever the mean is, if you go 3 standard deviations right or 3 standard deviations left, you've covered basically the whole curve. So I'll take the mean, 122,000, and add 3 standard deviations. That gives me 133,000 or so. And then if I take away 3 standard deviations, I get about 110,000. So on our graph, this point out here, this tail, this furthest point out where the curve is about collapsed onto the x-axis, that's got to be about 133,000, and on this other end, 110,000. So which one of these is like that? Which one of these goes up to about 133,000 there and 110,000 there? Yeah, this one. This one doesn't. This one's not even close. Maybe the mean is where it should be, but that point out there, that's way too far out. And then so is this one. So I eliminated C and D right away. Can't be C or D. That means it's A or B. But when I incorporate where that standard deviation puts this point out here and here, it's got to be A. That's the only one of those four choices that puts the far end on the left and the right of the curve in the right spot.